So we've played around with several different algebraic equations at this point, but in all of the instances we've seen, the equation has in fact been supplied to us. So now this very next example, you'll notice there's not an equation there. We're going to have to come up with one for ourselves. So we've got this guy, his name is Joe. He has a fair amount of cash on hand, and he wants to invest it. So he's got a couple of different investment funds he's willing to put it in, one with a 10% annual yield and another one that is riskier with a higher 15% annual yield. So the idea is we want Joe to use his money such that he ends up getting a total return of $12,000 in 1 year's time from when he first makes the investments. All right, so we got to try to sort of hash out all of the variable, all the quantities here and see how to assign a variable in this instance. So here's the way I would start it. So I'm going to call my variable x and this isn't the only way you could do it. That's one of those neat things about mathematics. It turns out the more you study it, the more different ways you find to approach the same problem. But for now, what I'm going to say, let's take that 10% fund, however much of Joe's money that he puts into it, we're going to call that guy X. All right, so if we're putting X dollars into the 10% fund, how much does that leave for the other one? I mean, you can play around with this with some numbers if it helps. Like, what if it's 20,000? What if it's 30,000? And sort of, build up where this is going to end up coming from. So, as it turns out, it's going to look like that. You might say, well, why is he having to think so hard about it? You just, take away the X value from whatever he had in the first place. We're assuming Joe uses all his money and doesn't just go buy Beanie Babies with any of it. So that means we have 100,000 minus X dollars. So we've got 100,000 minus X going into the 15% fund. So now we can work out an equation based on knowing that Joe wants to get back 12 grand at the end of all of this. So now the idea is, remember, we see these percentages when we use them in calculations. We almost always, for the purpose of this course, there are like 2 times all semester you will use a percentage as it is. Generally speaking, stick with convert the percentage into a decimal. Divide by 100, move the decimal point, whatever. So we have 0.10x. That's how much money Joe gets out of his X dollars in the 10% fund, plus 0.15 times the rest of his money, 100,000 minus X, and then that's got to equal $12,000. My head is obscuring the dollar figure. Hopefully, you'll process that. So now we just need to get X by itself. Now we're kind of back in the territory from our previous videos. I need to distribute the 0.15. So 0.10x, don't do anything with that guy yet, plus 0.15 times 100,000. That's going to give me 15,000 minus 0.15x equals 12,000. All right. So now we can subtract over this 15,000, and these 2 terms here, they're already on the same side, so we can just combine them. 0.10x minus 0.15x. So that's going to give me negative 0.05x. Remember, don't just do 0.5. That's like a 50%. That's going to draw somebody's attention. So these guys, the negative is important here, and you might get worried about it, but then you think, well, if I subtract the 15,000 over to isolate the x, 12,000 minus 15,000, the subtracted, the number you're subtracting is bigger than what you're starting with. So it kind of takes care of itself. So negative 0.05x equals negative 3,000, and now to get x by itself, I divide both sides by that coefficient. So x equals 3,000 divided by negative 0.05, and if I'm playing the cards right, x should be 60,000 in this case. Great. Now, Note, I still haven't put a box around this because it's not really the question we were asked. We needed the equation to solve to get to our answer. I mean, apart from, I guess, like brute forcing it, but we all have better things to do with our time than just to smash tons of numbers into these things to see what comes out, right? So we basically give this to Joe as like investment advice. So we invest $60,000 into the 10% fund. I just said at 10%. And then the rest of it, $40,000, is going to go into the 15% fund. So that's our answer in this, for this particular, problem that we were posed. We've been hired as a consultant by Joe. And as it turns out, Joe probably shouldn't have hired us. He probably could have done these calculations himself if he really needed to, right? Okay. So we're going to come back and talk more about equations momentarily, but it turns out in this section, and it's going to come up a time or two more in the course, we also need to deal with something that we refer to as an inequality. So I'm going to take a moment here, erase the board. Yeah, time. Okay. So inequalities, they kind of function like equations, except instead of an equal sign, they have an inequality symbol, a less than, a greater than. They could also have a less than or equal to, or a greater than or equal to, with a little bar underneath them. So they more or less function like equations with one key difference. Thanks to the fact that, inequalities are kind of like one-directional, like, 3 is greater than 5, you can't flip it around and say, 3 is less than 5. You can't flip it around and say 5 is less than 3, right? So, as it turns out, we have to be careful when we are dealing with an inequality if we have to either multiply or divide by a number that is negative. As the notes say, if that happens, the inequality symbol, in fact, needs to reverse. So there's two examples here. The first one I'm going to leave for you to work out. The second one is a little bit more involved. So let's take a look at that guy. All right. So, we have negative 3x minus 2. Then we have x plus 4 over 3. And we have a greater than symbol stuck in there. Note the lack of or equal to. That'll come in, that'll come into play momentarily. You may have noticed the directions also say something about graphing the solution set. We'll see what that looks like in a minute. Let's do the algebra first. First off, we've got a denominator. Fractions are scary. Get rid of the fraction. We multiply both sides by 3. So multiply both sides of that thing by 3. Make my camera all blurry because I stepped too fast. Come on, straighten out. There we go. All right. So distribute the 3. So this gives me negative 9x minus 6 greater than, over here, I just go poof, x plus 4. All right. So now I've got to get all of my x terms on one side, my numerical terms on another. So I'm going to subtract an x over. So that's going to give me negative 10x here, and then that guy goes poof. I need to get rid of this negative 6 to get rid of a subtraction. Note, we're not having to flip the sign yet. I said multiply or divide. We are adding a 6. So I guess it's not negative either. So just in case you tried to subtract a negative 6, I guess. So he goes bye-bye, but if we add 6 over to this side, 4 plus 6, hopefully you don't need me to tell you that's going to give us 10. All right. So from here, we've got negative 10x is greater than 10. To get x by itself, we need to divide by negative 10. Now remember, when we multiply or divide by a negative number, what do we have to do? We get to flip the inequality symbol. So that greater than now becomes a less than. Note it doesn't become an or equal to. It's just, the sign just changes directions. So 10 divided by negative 10, and that is in fact negative 1. So we have x is less than negative 1. So if you want to write that down, like that, great. X is less than negative 1. Now when it says graph, the idea is we're going to graph this thing on just a plain old number line. So all right, so we've got our number line right here, and we want to basically kind of sketch in a sense, all of the x values that satisfy this inequality. Well, That's everything less than -1. If you got it written like this, conveniently sort of a point of the inequality symbol tells you we want everything over on this side, because -2 is less than -1, 0 is not. All right. So you can shade this in on an number line yourself. When I'm writing it on the board, I usually try not to trace over because it's kind of hard to see. What I'll do instead is kind of just draw an arrow over top that I want everything off to the left of my target point, -1. Now, the question arises at this stage if, like, should I mark this off? You might, have had this discussion with people before. Do I, like, use a filled-in circle? Do I use, like, an open circle? Whatever it is. What determines that is, do I have an or equal to up here? In this instance, no, I don't. It's x is strictly less than -1, so we don't actually want -1 itself. In that instance, we want an open circle right there. If this had been an or equal to, if x is less than or equal to -1, then I'd want the filled-in dot. I'd want to color that guy in instead of just having like an open circle right there. All right. So that's dealing with inequality. So we've seen, an application where we had to build an equation. We've talked about the inequalities here. Like I said, I've left it to you, to do that other inequality example. Don't hesitate to reach out to me with questions if you want to, if something with it is giving you trouble. So we've still got some more applications I want to take a look at before we leave this first section behind. Bear with me. There is a light at the end of the tunnel.